We're going to be going over two sample hypothesis tests today involving proportions. Now, I notice at the top here, I just had a brief little review about confidence intervals and hypothesis tests, because we've done both of these. It's good to know the difference between these before we just jump right in. It's been a little while. Now, confidence interval is when you have no idea what your parameter could be. So, you take a sample, you get a statistic, in this case a p-hat, and then you go up or down the margin of error. You go minus, plus, and then you get a range of values where that actual parameter could be. And then you have a certain confidence level of where it could, of how confident you are. Or maybe you're 99% confident that the true parameter would be between whatever values you establish here. Maybe it's 90%. That's what a confidence interval is. You have no idea going in. Now with the hypothesis test, you have an idea what it might be, or you have an idea what it couldn't be, and then you're trying to prove something, or you're looking for evidence. Those are some key words here. So we're going to jump into some problems today. I'm going to do one where we explain all the concepts through, and then you're going to have some practice for homework. So we're going to start with this problem involving bullying. Now, at the beginning of the problem here, you'll notice that they talk about bullying being a problem at any age for students from 12 to 18. So that 7.2% of all students in this bracket have reported being bullied at school during the past 6 months, with 6th grade having the highest incidence and 12th having the lowest. Now, they give you some statistics here. We're not going to deal with that because here's what we're concerned with today. We're concerned with to see if there is a difference between public and private schools. We're only concerned here to talk about students were randomly selected from each. 200 as a matter of fact. And at 0.05 for our significance level, we want to see if there's a difference that can a difference be concluded. And then down here, they give us the results of two samples. So for a private school, they sampled 200 kids, and 13 out of 200 said they were bullied. In the public school, 16 out of 200 said they were bullied. So what we're going to do is we're going to set up a hypothesis test. First thing, you want to set up a null and an alternate. So you got your ho and your ha. Now when you're doing a two-sample test, what you're looking to see is if there is a difference in proportions. If you're trying to see a difference, that's what you're going to be proving. So what I'm going to do is for private, I'm going to establish this as P1, and I'm going to establish public is P2. So there are a couple of ways I could write my hypothesis here. I could go with P1 is equal to P2. Because your null is always dull, as we established in class, it's always going to have an equal sign in there. So P1 equals P2. Another way you could set this up, some people like to do it this way. P1 minus P2 equals 0. Because if the proportions really weren't different, you should be getting an answer of 0. Now for our ha, it all depends on what we're trying to prove, whether it's one-sided or two-sided. In this case, it's asking us, can a difference be concluded? So it really doesn't matter whether the private school has more, the public school has more. We're just trying to prove if there's any difference. So just like when you're doing hypothesis tests before, the same principle. In this case, we're going to do P1 doesn't equal P2. Or you could go with P1 minus P2 does not equal 0. That's what your null and alternates are going to look like for these. You're either going to have, your null is always going to be equals. Notice that's the common factor here. For your alternate, if you're just trying to prove a difference, then it's going to be doesn't equal. Now, if you're doing a one-sided test, like if we were trying to prove that, more kids at a public school get bullied than a private school, then you would use your inequalities just like you did before. P1 is greater than P2, or maybe P1 is less than P2. Those are a couple of options if you want it to be a one-sided test and you're trying to prove that one is more than the other. In this case, we're just trying to prove that they're different. That's the case. So I'm going to go with doesn't equal. But remember, null always has an equal sign. Your alternate is either going to be doesn't equal or it's going to be less than or greater than. And you'll notice I established my variables at the very beginning here. Private school is going to be P1. Public school is going to be P2. It's always good to do that. And I could even do that down here. It's good practice to get in the habit of doing that. So P1 equals proportion of, private school students bullied. And then for P2, we're going to make that public. Just make sure we're keeping it consistent. Yep. Always establish this. Don't just go, P1, P2, and then don't say what they are. You always have to establish what they're going to be. So I'm just going to copy and paste. I'm just going to change a couple things now. Gotta love technology. Instead of P1 here, I'm going to change that to P2. And then instead of private, I'm going to change that to public. All right, so I've got my null and my alternate hypothesis. That's half the battle. You get that started. Now the next thing we're going to be doing here is checking our conditions. You always want to check conditions. We always talk about that. Before you run your tests, you have to check your conditions. So let's talk a bit about the conditions. Now the good news is your conditions really haven't changed that much. For your conditions, first things first, hopefully you remember, random. The only difference is now you have to prove that both of them were random, that both samples were random. So let's see, I can go up to the top here, and it says randomly selected from each. Awesome, so that proves that it's random. So I'm going to put that down here, randomly selected from each. You always want to prove both cases. That's the only difference now. Instead of just proving that one sample is random, you have to prove that both. Same thing for all your other conditions. Like in this case, 10% condition. Typically, we just did that for one of our samples. Now we're doing it for both. So I'm going to do 200 is less than or equal to 1/10 of public school students. Does that check? I think it's very safe to say that 200 is less than or equal to 10% of public school students. Now I'm not done. I also have to do 200 is less than or equal to 1/10 of private school students. And I think it's very safe to say that that checks out. So that checks out. I've got my 10% condition done. So again, I mean, the good news is you're not really doing anything different than what you did before. You just have to do it twice. A lot of people hate that, but it's just the way it goes. So then we have one more condition. We've got 10%, we've got random, and then we've got large counts. Here's where a little bit of work comes in here. Because you're not just doing large counts for just one case here. You got to do it for 4. What do I mean by that? Let's take a look at the private school here. Out of 200, let's see, 13. Is that greater than or equal to 10? Certainly is. Now I also have to prove that 200 minus 13 is greater than or equal to 10. Because with large counts, remember you're checking successes and failures. In this case, a success is if a student says that they've been bullied. And if they haven't been bullied, we consider that a failure for the sake of this hypothesis test. So now I'm going to go to the public. I got to check it for that too. Let's see. So I noticed that 16 is greater than or equal to 10. That works. 200 minus 16, is that greater than or equal to 10? Certainly is. Awesome. So I've checked my large counts. And I'm all set with my conditions now. So again, what you want to check with your conditions. Random. Are they both random? Both have to be random. I'll put that here. Both samples have to be random. 10% condition. Again, both samples have to be less than or equal to 10% of your population. For large counts, again, you're pulling this from both samples. You have to prove it for both samples. If you're not proving it for both samples, then it's incomplete. Or if you're not meeting the conditions for both samples, then you haven't met the conditions for your hypothesis test. All right, so we've met our conditions here. We've set up a null and an alternate. Our last step here is we're going to run our hypothesis test. Now, for the sake of what we're doing, I think the easiest way to do this is using your TI. Now, I have a nice little device on my computer here, so I'm going to see if I can make this work. So we had 13 and 16. I'm going to remember that. All right, so I'm going to go here. Now, first thing you want to do is go with a stat, just like on your calculator. Go to calc. Now you notice you have all these options. Hopefully it's coming back to you a little bit. I'm going to scroll down. And we want to do, nope, we don't want to do that. We're going to go back. That's all right. We're going to hit, let's see, I'm looking for the button here. It's been a little while for all of us, right? Stat. Oh yeah, test. That's where you want to go. So again, walk you back to that. We're going to do stat, tests, and now I'm looking here. I'm going to be doing a 2-prop z-test. Why? Because I have 2 proportions here. That's what I'm doing here. I'm doing a test on 2 proportions. So you're going with 6 here, 2-prop z-tests. Sample 1, I had 13 out of 200. Sample 2, I had 16 out of 200. And then let's see. Now what do I want to establish? It's going to be that P1 doesn't equal P2 right here. If you were doing a one-sided test and you would go with either of the inequalities here where you have is less than P2 or is greater than P2, but we're just going with, you'll notice that right here, right above calculate, it doesn't equal. So I'm going to hit calculate. And there you go. I got all my information. So I'm going to take a picture of this because I'm going to use this. All right. This has all the important information you want to have. So make sure you're taking down all that important information. I'm going to copy that. And that's going to end up in Notability in a moment. All right. So now we have our information. Let's take a look. Our hypothesis, P1 doesn't equal P2. That's what we're trying to prove here. We have our critical z, and we have our p-value. This is the important one here. This is what you look at for a hypothesis test, your p-value. You'll notice that we have a very high p-value. Now, just like any normal hypothesis test, if your p-value is less than 0.05, and notice I should make that capital P, p-value, you would reject the null. Remember, it's only if your p-value is low. That's when you reject the null. In this case, if our p-value is higher than 0.05, we fail to reject. Remember, you never accept the null, but you can fail to reject it. So what conclusion do I come to now? Since my p-value, I'm going to put it in parentheses, 0.56 is greater than my significance level. Remember, significance level, we typically go with 0.05. We fail to reject the null. So then we go back up to our alternate up here. What were we trying to prove? We were trying to prove that the proportions weren't equal. So we don't have enough evidence to prove that. We have not proved our our alternate hypothesis here that they aren't equal. So we do not have enough evidence to prove the proportion of bullied private school and public school students are different. And I'm just going to shrink this down so I have more room. Portions of bullied students at public and private schools is different. Okay, so just to sum it up here, your null hypothesis, always an equal sign. You're establishing that the two proportions are equal. Your alternate is either that they're not going to be equal, if you're looking specifically to see if they're different, or if one is greater than or less than the other. Then you got one-sided test where you'd have, again, P1 would be greater than P2, or maybe P1 is less than P2. That's with your one-sided test. Just, again, not any different than what you're doing with your other hypothesis tests here. Then your conditions, same conditions, random, 10%, large counts. You just have to prove it for both samples this time, both populations. And then you run 2 prop z tests on your calculator, you get yourself a nice p-value. You'll notice that I'm not necessarily having you guys calculate this out and go with the formula. The reason is it gets a little tricky a little bit down the road, so I figure go with the calculator function for right now and you'll be in pretty good shape. Anyway, hopefully this helps you. I'm going to be posting up another video to go through the second problem. And you're going to have some problems like this for homework. So if you have any questions, you can post them in the discussion forum. Or if you're not a student of mine and you have a question, feel free to email me at statsgamosh@gmail.com.